A groundbreaking flight test explores potential for long-distance, heavy-payload drone operations, targeting crucial advancements in emergency response capabilities. By DroneLife staff writer Ian J. McNabb, this article published in collaboration with JUIDA, the Japan UAS Industrial Development Association, the Akasaka Takeshi Laboratory of the Kanazawa Institute of Technology's Department of Aeronautical Systems Engineering conducted its first flight test of a large drone on Tuesday, December 10th, at the Hakusan Radio Control Club's radio control airfield on the Tedori River riverbed. The Kanazawa VTOL drone test, the drone, which weighed over 90 kilograms, nearly 200 pounds, with its included battery packs, also featured a 40 kilograms payload. According to their press release, there are no extant examples of a VTOL-type winged electric drone with a maximum payload of 50 kilograms and a flight distance of over 50 kilometers available in Japan. The organizers were quoted as saying, "There are no examples of VTOL-type winged electric drones with a maximum payload of 50 kilograms and a flight distance of over 50 kilometers in Japan yet. In this flight test, we tested whether the drone could lift off with a 20 kilograms weight and a 40 kilograms weight, and the prototype, without wings, successfully lifted off." According to their press release, during the Noto Peninsula earthquake in 2024, rescuers faced an unexpected problem. The shaking did serious damage to the port's infrastructure, making it impossible for ships transporting relief supplies to dock. The drones take several hours to charge, and spare batteries must be prepared before they can be used to transport supplies. The project, led by Associate Professor Akasaka, initially wanted to develop a drone that could fly from Nano Bay to Suzu City, but because 60 kilometers one way was considered too difficult with current technology, he set a development goal of flying 50 kilometers. On the day of the flight test, a prototype aircraft was used to conduct technical studies in advance on how to achieve a maximum payload of 50 kilograms. The prototype aircraft is 2.5 meters wide x 1.5 meters deep and has 8 propellers. Based on the data obtained from this flight test, the Akasaka Laboratory will proceed with the development of a fixed-wing prototype, with flight tests scheduled for early March 2025. The leaders of the research project include Associate Professor Takeshi Akasaka, Department of Aeronautical Systems Engineering Ryuhei Oga, second-year master student in mechanical engineering at the graduate school Shunpai Maruyama, fourth-year student, Department of Aeronautical Systems Engineering Takuma Kawasaki, fourth-year student, Department of Aeronautical Systems Engineering